So I want to see if we can figure out this log base 2 of 10, finding out what that equals without going through all that guessing and checking that we just went through. So let's just start with, this. The log base 3 of 7. I want to evaluate that. Now, if you think back to yesterday, evaluating that, the first thing that we do is set it equal to x. And the next thing we like to do is to go from log form back into exponential form. 3 to the x is equal to 7. Then we like to try to get like bases. But what's the problem? You can't get like bases here. If you can't get like bases, then we learned yesterday the way that you solve it is to do what? Take the common log of both sides, right? And when we take the common log of the left, the x comes out in front. And we end up with that. And then to solve for x, you end up with the log of 7 divided by the log of 3. So x equals the log of 7 divided by the log of 3. When we started out with log base 3 of 7. So everybody see that? Okay, yes. Is it always going to be like that? Well, let's see. That's a very good question. Let's run through this one and see if the same thing happens. Set it equal to x. Right? What are we going to do? Put it into exponential form. The base is, the exponent is x, and it's going to equal 5. Can you get like bases? Nope. So if you can't get like bases, then what do? Take the common log of both sides. X times the log of 12 is equal to the log of 5. And once we do that, then we're ready to do what? Divide by log of 5. And we end up with the log of 5 divided by the log of 12. Did it work? Do you see the pattern? Yeah. So on that last example that we had earlier, when we had the log base 2 of 10, an easy way to write this is just like what? Right? Log of 10 divided by the log of 2. Now the log of 10 you should all know. 1. So this turns into 1 divided by the log of 2. So go ahead and take your calculators and let's see how close we got by doing our guessing and checking, and do 1 divided by log 2. And what is it about? 3 point, and we had what, 3.322? Yeah, you guys did really well, okay? But isn't this a lot faster? Okay? This process right here is called the change of base formula. The change of base formula says this. If you have the log base b of a, it can be rewritten into 2 logs that are being divided, where the top log is the log of a divided by the log of b. Now, we chose base 10 when we did this in those previous 2 examples. Why? Because then we can calculate it with our calculator. The thing is, did I have to choose base 10? No, I could choose any base I wanted as long as what were true about the 2 bases. They were the same. So to make this formula complete, I'm going to put down here a base c. It doesn't matter what base you change it to, as long as it's the same base, you've got it. Okay? So from now on, if you need to evaluate something like this, it shouldn't take you much time at all. The log base 5 of 7 is just going to be what? The log of 7 divided by the log of 5. Okay? And you can pick, again, you can pick any base you want. I could have put log base 3 of 7 divided by log base 3 of 5, although is that going to help me very much? No. I could pick base 7, log base 7 of 7 divided by log base 7 of 5. Is that really going to help me a lot? No, the top will be okay, right? Log base 7 of 7 will be 1, but that whole log base 7 of 5 business isn't going to be too helpful. Okay? Do you see how that change of base formula is working? Yes? Any questions on that? Okay. Then the next thing that I want to look at today is solving logarithmic equations. And logarithmic equations, as you know, are equations that take the log of the variable. There has to be a variable in what you're taking the log of. And I'm going to just put up some steps to follow when we solve these. The first thing when you're solving a log equation is to get all of the logs on one side. Now, what do you think is going to have to be true about all the logs in a log equation problem? They're going to have the same base, otherwise we're probably going to be stuck, okay? Or at least the ones that we're going to look at now are all going to have the same base, okay? So we're going to get all of the logs on one side. Now, if you have more than one log, any ideas what you're probably going to want to do with those logs? Do what? Yeah, condense them all together using properties of logs so that you get just one log. So condense any logs using the 6 properties of logs. You want to condense them so you get just one logarithm. Now, remember when we solved exponential equations, we went from exponent form to log form because that's how we got the x out of the exponent spot. Guess what we're going to have to do when we're solving a log equation? We're going to have to change it back into exponential form. I told you it would be going back and forth a lot. So that's what you're going to do next. You're going to put it into exponential form, and finally, after it's in exponential form, we'll go ahead and solve for x. So let's just look at a couple examples. So here's the first one. Log of 3x plus 1 is equal to 5. Okay, are all the logs on one side and everything else on the other? Okay, do we have it condensed into one logarithm? Yep, so we are ready to put it into exponential form. What's the base? 10. Remember, it's that implied 10 when you don't see a base. Okay, 10 to what power? And what does that have to equal? Okay, I hope you all know the 5th power. 100,000, is that right? Okay, is equal to 3x plus 1. Could you solve that equation? Yep. Subtract the 1 from both sides, and you're going to be down to and then finally, divide by 3. All right. You see how that worked? Any questions on that example? Nope. Okay. Let's look at this one. 2 log x minus log 3 is equal to 2. 2 log x minus log 3 is equal to 2. All right. So if you look at this one, are all the logs on one side and everything else on the other? Yep. So what are we ready to try to do with those logs? We're ready to try to condense them. Now, when you go to condense, what do you have to take care of first? That 2. What does that 2 become? An exponent on the x. So we get the log of x squared minus the log of 3 is equal to 2. Okay, we still have 2 logs, but from your properties of logs, you know that it's going to turn into division. So we're going to have the log of x squared divided by 3 is equal to 2. Now, as soon as you get it down to 1 log, now it's ready to go into, bless you, into what? Exponential form. So the base is 10. The exponent is 2 is equal to x squared over 3. So let's see, this will be 100. And then you'll multiply by 3, so you'll get 300 is equal to x squared. Therefore, x is equal to 10 root 3. Would it still be plus or minus? That was going to be my next question. Is it going to be plus or minus? Look back at the original equation. See where x is? It's right here. Think about the things that we take the log of. You can't take the log of a negative number, right? So can I put plus or minus in there? No. Okay? In this case, that's your answer for x. All right? Any questions on that one? Okay, let's look at, perfect. How about this one? 2 log x minus 1 is equal to the log of 3. 2 log x minus 1 is equal to the log of 3. So what do we have to do first? Subtract the log of 3 because I need all the logs on the same side. What about that minus 1? Put it to the other side, okay? You want logs on one side, everything else on the other. Now, what can you do on the left-hand side? Condense them, right? Combine them all, and it's going to become the log of over 3. I think that was the same as the last one, wasn't it? Now, it's what? Not 3 to the first. The base is, yeah, there you go. 10 to the first is equal to x squared over 3. So 30 is x squared. So x is the square root of 30. There you go. Any questions on that one? Okay, what about this last example? The log of x plus 21 plus the log of x is equal to 2. Okay, are all your logs on the same side? Yep, so what are you ready to do with them? Condense them. And how do you condense them since it's 2 logs being added? You turn it into 1 log where you're multiplying, right? So we have the log of x times x plus 21 is equal to 2. Now it's ready to go into exponential form, so it will be the base is 10. The exponent is equals. Okay, and some of you have already distributed, and that's fine because you're going to need to distribute. Okay, so since it's an x squared equation, you have to do what with it? Set it equal to 0 and try to factor it. This will be minus 100. All right, so it's going to be, if it factors, it's going to be x and x, right? And it's going to be a plus and a minus. Plus 25 and a minus 4. That means x could either be negative 25 or positive 4. Well, let's go back and check. Is it okay for it to be negative 25? No, why not? Is it okay for it to be 4? Yes, so get rid of the negative 25, keep the 4. Okay. Any questions on these log equations? So 2 new things today, log equations and your change of base formula. Okay? You may see some exponential equations mixed into your assignment as well, but here's your assignment.